Hello and welcome back. We are working on Chapter 7, Section 3, which is Solve and Write Subtraction Equations. This is going to start on textbook page 535 and go all the way through textbook page 538. You want to remember, as usual, to have your regular pencil out with your eraser to make sure that you're doing all of the on your own problems with that, so that if you make an error, you can always go back and correct it, because that's what you should be doing after you push play. You should correct your errors on the on your own problem. Also, you want to have your colored pencils or pens out so that you can draw attention to any important parts within the textbook. You need your textbook, of course, because that's where all the notes are going to be. You want to be thinking about the things that you're listening to. And last but not least, you want to have your headphones on so that you can actually listen and pay attention solely to the video. Today, we're going to get started on textbook page 535. It's going to be right here where you see this guy bowling. So let's see what this is all about. It says, scan the lesson and predict two things that you will learn about solving and writing equations. Solving and writing subtraction equations. So I've written the first one here for you. It says, I'll learn to solve by adding. So just like before, we learned to solve by subtracting. Today, we're going to learn to solve by adding. And then it says, I will learn about the addition property of equality. Now, you want to remember, and we're going to talk, of course, more about this while we're working on it, but you want to remember that when it's talking about addition and subtraction, property of equality, we're actually talking about what's being done to the problem, not what type of problem it is. So take a look here under the real world link. It says Megan's bowling score was 39 points less than Charmaine's. Megan's score was 109. So remember, I've put a blue box around the 39 points less than. Remember, it's usually easy, or easiest rather, to find the total. That's usually the best thing that you can find. And when it says Megan's score was 109, that word was is a good indication that that's where the equal sign is going to go. So it says let S represent Charmaine's score. Write an equation for 39 points less than Charmaine's score is equal to 109. So we have S minus 39 is equal to 109, because remember, even though it says 39 points less, which would normally in our brain make us think 39 minus, remember we have to switch the order because it's less than, more than, greater than, or fewer than. Then it says to use the number line to find Charmaine's score by counting forward. Because remember, Charmaine's score was obviously going to be bigger than the 109 because you subtracted 39 from it. So what we're going to do is we're going to plot our first point right there at 109. So you want to go ahead and do that where I've done that now. Then you're going to make a hop. And notice I put a little plus 10 inside there. I did that because we're going from 109 to 119. How many of those hops do we need? Well, we're going to need 39. So right now we have 10. So now we're going to do another 10, which brings us to 129. Another 10, which brings us to 139. And then here's the tricky one, because remember there's 10, 20, and 30. And remember we need to add 39 slots. So there's our 9 slots. And that brings us to 148. So now we know that S, or Charmaine's score, is going to be equal to 148. What operation does counting forward suggest? Addition. That makes sense, right? Now you're going to be looking at textbook page 536. On textbook page 536, you see solve an equation by adding. Because addition and subtraction are inverse operations, you can solve a subtraction equation by adding. So I've included my cute little face here, not mine, not my daughter's, but cute little image that I found here on Google, and it's got the opposite. She's mad or sad or upset, and then she's happy. So hopefully that will help you remember along with your math rap video. Sorry about that. So again, you just want to remember, because addition and subtraction are inverse operations, you can solve a subtraction equation by adding. So right here, you want to make yourself a little note. Teach me how to solve it. So remember in the song where he says, if I say skinny, you say fat. And it's the same thing, you know, if the problem is adding, you simply subtract. If the problem is subtracting, then you add. So just remember the song. Now we're going to go ahead and look at method 2. So it says to solve x minus 2 equals 3 and to check your solution. So we're going to be using, and I'm sorry, actually it was method 1. We're going to be using the model. So this model is a little different, so you just want to make sure that you pay close attention. So as you can tell, and I do want you to draw this again, you can see that you have one bar and that's labeled x. That's the entire bar, okay? Then you have another bar that's separated into 3 and 2. So that's also labeled X because that's the whole bar. Now, if you work backwards to solve the equation, then you're going to rewrite the equation as an addition sentence and solve 3 plus 2 equals 5. Oops. So it says to work backwards, so you want to write that. What does that mean? That means that you can go, okay, well, if x minus 2 is 3, then that means that the x had to be larger, had to be a greater number than 3 because you subtracted 2 from it. And if you say how much greater does it have to be, it has to be 2 greater because you subtracted 2. So now you're going to work backwards, you're going to add 3 plus 2, and you will get 5. The next example for method 2, which is the one that you're going to be using most often, says x minus 2 equals 3. So you want to rewrite that problem again, just like I've done here. And you are going to add 2 to both sides. So just like we did for addition when we subtracted 2 from both sides, now because this is x minus 2, we're going to undo subtraction by adding. And remember, what you do to one side, you must do to the other. Also remember, the whole point of this is to get the variable isolated, alone, all by itself. So now we're going to cross out minus 2 plus 2 because that would give you a 0 pair. And then 3 plus 2 gives you 5. So now you need to write your final answer, which is x equals 5, and put a box around it. But you're not finished yet, because now you need to write the check in a bubble out to either the right or the left. I do not want it underneath the problem, right or left. And then you're just going to go ahead and write the original problem, x minus 2, like I've done here. 5 minus 2 equals 3, and 3 does in fact equal 3. So check, you've done that correctly. You want to make sure that all of these steps are listed. I'm going to be looking for each one. So 1, 2, 3, 4, 5. So this would be a 5-point problem to make sure that you have each one of the steps shown. So you can see you have original, inverse, solve, answer, and check. I put that in a pink box. So I need you to make sure that you write that off to the side somewhere. Make sure that you have that little star there, everything, so that you know that this is important. Now we're looking at textbook page 537. So let's see what we have here on this page. It says if you add the same number to each side of an equation, the two sides remain equal. So this looks a whole lot like our subtraction property of equality. What you really want to note here, and the most common mistake that's going to be made on the vocabulary test and even in just the question and answer sessions in class, is going to be that you're going to look at it and you're going to think, oh, the addition property of equality applies to addition equations, and that's incorrect. The property is named for what you're doing to the equation. So what that means is this has to be a subtraction problem in order to apply the addition property of equality. So I've written that note here, and I want you to write it as well. So it says, remember, the property is named for what you do to solve the equation. So it's not named for the type of equation. So as you can see, you have the x minus 2 right here. That x minus 2 equals 3. That's a subtraction equation. But you're going to apply the addition property of equality because you're going to say, if I add 2 to both sides, the equation remains equal. So it's not the given operation, it's what you're actually doing. All right, so now we're going to go ahead and take a look here at example 2. So your focus in these problems, in the word problems, really needs to be on the word problems because that's going to be the trickiest, where you have to write and solve the equation. So let's go ahead and take a look at this problem now. It says at age 25, German Titov of Russia was the youngest person to travel into space. This is 52 years less than the oldest person to travel in space. So let me go ahead. Okay, so I reboxed in pink there. So 52 years less than. So I've put that in a box by itself. The oldest person to travel in space, John Glenn. How old was John Glenn? So you're solving the problem for the age of John Glenn. So it says to write and solve a subtraction equation. So that's really important too, that they told you that it's got to be a subtraction equation. So in words, you can see oldest age minus the youngest age is 52 years. So as you can see, I've drawn one bar here and I put oldest and then the letter A, okay? And so what that's supposed to represent, obviously, is going to be John Glenn's age. So what that's supposed to represent is the oldest age in space, which was John Glenn. So now what you're thinking is it's the oldest age minus the youngest equals 52. So let's go ahead and draw another bar. All right, so as you can see, I put a bar around the big green one because I'm saying that's John Glenn's age. Now we're going to identify the pieces here. We know that if we take John Glenn's age, which is the oldest, and we subtract this 25 right here, then we're going to get equals 52 right here. So now let's go ahead and put that into an equation. So we have a that came from right here, minus 25, which came from right here, equals 52, which came from right here. And so now you're going to solve using inverse operations. And you find out here that John Glenn's age was 77. And so then you're going to check. So you need to plug that back in just like we've been doing. And as you can see down here where I've done it in blue, or off to the left where I've done it in blue, you can see that a minus 25 equals 52. 77 minus 25 is in fact 52, so we know our problem is correct. Now I want you to go ahead and pause the video so that you can work this out. Now I want you to keep in mind, because they just gave us an example using a model and then showing it through words and through the inverse operations, I would like you to do the same. So go ahead and create a bar diagram just like we did in the last problem to solve this problem. All right, hello and welcome back. Hopefully you did well with this got it problem. It says Georgia's height is 4 inches less than Sienna's height. Georgia is 58 inches tall. Write and solve a subtraction equation to find Sienna's height. So we need to find Sienna's height, okay? And we know Georgia's height. So Georgia's height is going to be the best thing that we have to work with right now, because it says Georgia is 58 inches tall. That word is very important, because that indicates to us that there's an equal sign involved right there. So what we're going to do is we're going to go ahead and immediately place that equals 58 right there, because we know that that's on the right side of the equation. You could put it on the left, but what we're saying is we know that's the number that's all by itself. That's the number that's for sure. So now we need to figure out what we need to put on the left side of the equation. So it says Georgia's height is 4 inches less than Sienna's height. So what we're saying is 58 is 4 inches less than Sienna's height, which we could call S or H. So then now what I've done is I went ahead and defined the variable. So let's do this actually. Let's go ahead, since S is going to be Sienna's height, and we know that Georgia is 58 inches tall. Let's go ahead and put that 58 inches is, that's an equal sign word, so 58 inches is 4 less than Sienna. So 4 less than what? Sienna. So now we're going to go ahead and put that in there. So it should say S minus 4. Now there were two different ways that you could set this problem up. So this was the first way, 58 equals S minus 4, or you could have written it the original way that I started to write it. Either of those two would be fine. So it would be fine whichever way you wrote it, this way in yellow or the one that I have in white and blue. So now that we have that, we can go ahead and solve it. Now I'm also going to use a diagram, or a model rather, to solve this with you. So let's go ahead and think about that model for a second. So if we look at the problem S minus 4 equals 58 that I have over here on the right, you need to think to yourself, okay, if we subtracted 4 and we got 58, then that must mean that Sienna's age has to be older than the 58. And by how much? Well, it's going to be by 4. So it'll be 59, 60, 61, 62. So let's go ahead and see if we can put that into a model. So as you can see in the model that I've written here, or that I've drawn here, you've got Sienna's age, which is the whole bulk, that top bar right there. And then you have Georgia, which is the 58. And then you have that Sienna, the total, Sienna minus 4, is going to give you the 58. So now to figure out what that whole bar is right here, you're going to just go ahead and add 58 to 4. So 58, 59, 60, 61, 62. So now I went ahead and I erased the other way that we wrote the problem. So now I'm going to also, let me make Sienna's height smaller here. Okay, so as you can see, we have that equation again. Now we're going to go ahead and do the inverse operation so that we can undo this subtraction. So we actually say to ourselves, what's happening to the S? Well, 4 is being subtracted from the S. So that means to get rid of it, we need to add 4 to the side with the S and the other side, because what you do to one side, you must do to the other. So now you have 58, 59, 60, 61, 62. So 62 goes right here. Then you need to write your answer, which is S equals 62. Put a box around it, just like we did when we were doing the addition problems. And then, yep, you guessed it, you want to go ahead and do your check right out to the right. So for the check, it would be great if you would write the word check, put it in a bubble, and then you want to write your original equation, which was S minus 4 equals 58. Then you want to plug in what you got. So you got 62 for the S, minus 4 equals 58. And then you actually want to do the math on the left-hand side. 62 minus 4, you want to say to yourself, what is that? Well, 62 minus 4 is in fact 58. So 58 is equal to 58. Notice I didn't change anything on the right-hand side of the problem. The 58 stayed the same the whole way down. So we're checking to see if both sides balance. So for your final answer, you want to make sure that you have put a box around your answer, which is s equals 62, and you also need a box around your equation because this was a word problem and you came up with that equation. So this is what a correct answer would look like for this word problem. Now let's go ahead and look at textbook page 538. On textbook page 538, it says Rasheem's rollerblades cost $70.25. Cost $70.25 less than his bicycle. His rollerblades cost $43.50. How much did the bicycle cost? So write and solve a subtraction equation. So in this example, you can see what we've done here is the words say cost of the bicycle minus $70.25 is $43.50. Okay, so as you can see, I went ahead and defined the variable, which says B equals the cost of the bicycle, and then I drew my big bicycle chunk there. So that top bar is going to represent the entire cost, and then you want to think about what it said again. It said Raheem's rollerblades cost $70.25 less than the bicycle. So we're going to break this apart here, and we're going to write 70.25, and then it says, but his rollerblades cost $43.50. So we're just going to go ahead and put the $43.50 in that tiny box. Okay, so as you can see, I went ahead and put the $43.50 there. And now because you have the $43.50 in there, you can go ahead and put a bracket around this and say, okay, when we add all of this together, the $70.25 and the $43.50, let's go ahead and do that off to the side. Using the model, you get $113.75. So now we have used the model. Now I want you to go ahead and set up an equation. I'm going to go to the next screen to do that. All right, so now in the top left corner you can see a small screenshot of what we had just come up with on the last screen. So now we've done the model. Let's go ahead and write the equation. So if you remember in the problem, it said that Raheem's rollerblades cost $70.25 less than the bicycle. So you know that that's the part that's going to have the variable with it because you don't know how much the bicycle cost. So remember when we were setting up equations before, or when we were setting up expressions rather, before, you know that less than, more than, greater than, fewer than, that you needed to switch the order. So let's go ahead and do that now. So as you can see on the left-hand side here, I went ahead and set up the equation. Now, when you're looking at the word problems and you need to figure out what goes on each side, you want to think of it in terms of the right side and the left side, obviously. So the part here where it says his rollerblades cost $43.50, that makes you understand that that number is what's on its own after the equal sign. Then everything else, when it says Raheem's rollerblades cost $70.25 less than his bicycle, you know that that's going to be on the other side with the variable because it's less than the unknown. Does that make sense? Hopefully it does. So now with the equation here, we can go ahead and perform the inverse operation. So we're going to add 70.25 to both sides, making sure to cross out this 70.25 because subtracting 70.25 and then adding it back is offsetting it. So you're at a 0. And now you have 5 plus 0 is 5, and 5 plus 2 is 7. 3 plus 0 is 3, and 7, 8, 9, 10, 11. So now you get $113.75. You want to make sure that when you're writing your answer, you're now telling me that B equals, because notice B is the only thing we have left on the left-hand side. B equals 113.75. Make sure you have a dollar sign at the end. Put a box around it, and you're also going to need to have a box around your original equation, which was B minus 70.25 equals 43.50. And that's because this was a two-part answer. So you just want to make sure that you've answered both parts of the question. So you've written the equation and you've solved it. Last piece to this is you want to make sure that you have checked it as well. So now off to the side, you can see where I've checked it in blue and green. I started with the original equation that we came up with, which was B minus 70.25 equals $43.50. Then I plugged in my answer, which was $113.75 equals $113.75 minus $70.25 equals $43.50. And then again, one of the most important parts here is that I actually did set up the subtraction problem so that I could make sure that that subtraction does work out, and then and only then will I put a check mark on the bottom. So right here you can see we have stop and reflect. How is solving an addition equation different from solving a subtraction equation? Explain below. So I set up two very simple equations here for you so that you could explain using these two equations. Okay, so as you can see, I worked out both of these problems here, and the number one difference where it says how is solving an addition equation different from solving a subtraction equation? Well, here's the answer. To solve an addition equation, you must subtract. To solve a subtraction equation, you must add. So that's the main difference. And I've written that here. Up at the top in blue, it says you subtract to solve addition equations and you add to solve subtraction equations. And actually, I just realized that my arrows are pointing to the wrong ones. So let's go ahead and make sure we clean those up here. So now we've got it. So you add to solve subtraction equations, so that arrow goes here, and you subtract to solve addition equations, that arrow goes here. So make sure you have those two explanations and the two examples. So now, are you feeling like the purple one or are you feeling like the yellow minion? You get to decide. And don't forget, as you're starting your guided practice, you want to show the inverse operation. You want to be polite, meaning do unto one side as you do to the other. Be sure to check your work, and above all, do your very best. For your homework assignment, go ahead and do numbers 1 through 4. I can't wait to see you next class.